Hello everyone, and welcome to our 25 gig I/O Hangout. My name is Ashley Kreiser. I'm a Marketing Communications Analyst for TE's Data Communications Business Unit, and I'm joined by two global I/O product managers, Melissa Knox and Lucas Benson, who are going to share some insights about the push for 25 gig as well as TE's 25 gig I/O portfolio. We will have a question and answer session at the end, so if you have any questions throughout the presentation, please type them into the Q&A box. And now I'll hand it over to Melissa and Lucas.
Hi, and thanks for joining us today. I'm Melissa Knox, a Global Product Manager here at TE for some of our high-speed I/O products like SFP, SFP Plus, and ZSFP Plus.
Hi, I'm Lucas Benson. I'm a Global PM for some of our other high-speed I/O products, including the QSFP form factor from 10 to 25 gig, CXP, and CFP products as well.
Okay, we're going to go ahead and get started. If we look at standards that drive I/O, high-speed I/O in general, you can see listed here is InfiniBand, Ethernet, fiber channel. InfiniBand Trade Association is defining a 25 gig enhanced data rate now, as well as the IEEE has put together a working group for 25 gig specification. The Ethernet Alliance and the OIF groups have been working on 400 gig interfaces. And Fiber Channel is getting ready for a public release of the 128 GFC specification. In the market, there are many transitions happening. By 2018, there are expected to be 21 billion devices online. Global IP-connected devices and machine-to-machine connections are growing faster than global internet user growth. The 28 billion devices or connections in use by 2018 will be approximately 2.7 devices or connections per person. Broadband speeds are expected to grow to 42 megabytes per second by 2018. And finally, we'll see a transition in how we are downloading or watching our video content. By 2018, less than half of all video internet traffic will be displayed on a PC screen, with 54% of that traffic being HD or Ultra HD quality. In order to meet this drive for bandwidth, we need connector systems that are not only designed to reach higher data rates, but also include longer reach, lower power consumption, higher faceplate density, common pluggable interfaces, fewer fibers and cables, lower CapEx costs, and increased reliability. The 25 gig I/O product selection has been designed based on these needs. If we look at transceiver shipments, from last year until 2018. Again, so this is light counting is the source for this. So this is just to show the trend, not overall sales or overall market for transceivers. But if we look at the light counting data just as a trend, you can see that 10 gig is really the breadwinner of the industry for now. All of the buzz in the industry, however, has been centered around 100 gig. So as 10 gig will continue to replace 1 gig, 100 gig products like CFP, CFP2, CFP4, QSFP will start to ramp in 2018. If we look at a further breakdown of those 100 gig products by form factor, you can see that QSFP or QSFP28 is expected to be the clear winner. As we just saw, 100 gig products that include the QSFP that we discussed will be starting to ramp in 2018. The biggest issue with 100 gig products is that currently the only interval between 10 gig and 100 gig is 40 gig. That doesn't neatly aggregate over the 100 gigabit per second. An open industry consortium has been formed between Arista Networks, Broadcom, Google, Mellanox Technologies, and Microsoft to bring 25 and 50 gig Ethernet to cloud scale networks. In other words, we know customers are going to use 100 gig at the top of rack. 25 gig products like ZSFP or SFP28, which is the industry name, will be needed at the entry point to that server and storage device where currently 10 gig products are used today. Design-in of 25 gig solutions now will enable cost-effective scaling of network bandwidth delivered to those servers, to those storage and server endpoints in next-generation cloud computing. Use of 25 gig products like ZSFP Plus and ZQSFP Plus now for improved margins and performance and scalability to 25 gig speeds later with less CapEx. If we take a look at the TE 25 gig I/O portfolio and roadmap, you can see on our standards sheet here, we've just kind of tried to list the I/O protocol and then that are used in I/O products, and then those TE products that correspond with that protocol. So you can see the big ones listed here. Ethernet is in blue, InfiniBand in orange, and Fiber Channel in yellow. In the discussion today, I'm going to focus on those products that meet both Ethernet and Fiber Channel, which are ZSFP Plus. And Lucas will look more at the higher speed products like ZQSFP and CDFP. On our roadmap, you can see that we have recently released or are releasing many of the Z series products. Z series is actually a trademark of Molex, and we'll talk about that a little later when we talk about our products and how they're interchangeable. But the standard or industry name for Z SFP Plus is SFP28, and then same for Z QSFP, that would be the QSFP 28 industry name. So we're currently in production on many of the ZSFP Plus to include the SMT Connector and our stacked products. We are releasing the OneByOne cages very soon. We're in full production on the ZQSFP product line and working to develop products like CDFP, CFP2, CFP4, and in addition, we're always looking at the next generation, what comes after 25 gigs. So currently we're working on a 0.6 millimeter pitch I/O solution. If there's any interest in this, you can contact us. Our email addresses will be included in this presentation toward the end, and we'd be happy to go into details. And then finally, perhaps taking something like a SFP size to a 56 gig I/O solution. So if we look at specific products here at TE, our ZSFP Plus product, again, is released. This is the overview of the SMT connector. As we have noted for today's chat, TE and Molex have partnered together to provide interchangeable 25 gig solutions to the market. This effort is similar to other second source agreements between TE and Molex in the high-speed I/O space. The ZSFP Plus SMT connector is backward compatible with the SFP Plus form factor in PCB footprint and mating interface. The SMT connector is currently in production and again can operate at 10 gig or 16 gig levels with substantial margin while providing cost-effective scaling opportunities to 25 gig later. Samples are currently available at te.com. This graph is showing the differential insertion loss of the ZSFP Plus SMT connector in dB versus gigahertz. You can see a smooth performance between 10 and 15 gigahertz. On the ZSFP Plus 1x1 and 1byN cages, we're working to get these in production now. The 1x1 is still in the design phase with an expected release late this year. The 1byN cages, including 1x2, 1x4, and 1x6 configurations, are available for samples now with a full release in January 2015. The 1x(N) cages have the same footprint as the SFP plus enhanced cages, and we've added some additional insulation material to the bottom of the cage in order to achieve improved EMI performance. Again, these cages are interchangeable with those provided by Molex. We have we have even made changes to the appearance of these cages so that they look more like those from Molex, which is something that we have not done in the past on our 10 gig solution. Here you can see the improved performance of the ZSFP Plus cage over the 10 gig SFP Plus solution. Looking at the graph, we are again showing measures by dB versus gigahertz. The red line indicates the performance of the SFP Plus cage, while the blue is indicating the performance of the Z SFP Plus cage. At 10 gigahertz, you see a 10 dB improvement in the Z SFP Plus cage. On our 2x(N) product line, we are completely tooled in the 2x1 through 2x8 configurations. Unlike the 10 gig SFP Plus solution, we will also be offering a 2x12 configuration in ZSFP Plus. As we talked about earlier, we have seen a demand for increased port density in the market and have had a lot of interest in a 2x12 configuration. Samples of the 2x12 will be available next month with a full production release in December of this year. Additionally, we are offering more of a variety in the light pipe configurations. We're still offering the standard setups, no light pipes, all 4 light pipes, etc. But we have added a 3 light pipe version and a reversed outer light pipe option. Finally, we will be offering a thermally enhanced version later this year. The first configuration to have this option will be the 2x12, with others to follow. This design consists of strategically placed square holes in the latch plate area and on the back wall of the cage for front-to-back airflow. Initial thermal results show a lower temperature rise than the standard cages. A test report will be available upon release of the product. And finally, I just want to take a look at the performance, the EMI performance for the stacked cages. The graph, again, is showing measures by dB versus gigahertz. The red line indicates the performance of the SFP Plus cage, while the blue is indicating the performance of the Z SFP Plus cage. From 10 to 15 gigahertz, you see a consistent improvement in the Z SFP Plus stacked cage. Next, Lucas will take a look at some of his product sets.
Okay, thanks, Melissa. So I'm going to cover some of the form factors that I have responsibility for. Some of the higher density form factors, including ZQSFP, which is QSFP28, CDFP, and CFP2 and 4. So this is just one slide showing what we're planning on doing with our portfolio for QSFP28. You know, in the past, TE has looked at providing certain cage configurations or certain cable assemblies, or investing in certain optics for different form factors. But for QSFP28, we see this as such a huge driver in the market over the next 10 years that we're investing a lot of money into the optics space. I've seen, you know, if you haven't seen our CoolBit optical engine release, it would be something for you to check out on te.com/CoolBit. But we have optical transceivers, we have AOCs, we have surface mount connectors, cages, stack cages, but we also have an entire team that is dedicated to looking at alternate materials and also for thermal modeling. We know that, you know, the transceiver MSA could potentially be going to 4.5 watts. So this will cause certain issues in your system, and you know, we obviously are looking into solutions for you, which I'll get into in a little bit. So starting with the surface mount connector, we decided to tool the same product as Molex, obviously through our second source agreement. We have, you know, similar or same material, same performance, same everything, looking at cross testing and everything. So that way, when you design in TE, you design in Molex, you can have two sources that can go into your entire system. So this is 4x25, supporting 100 gig Ethernet and 100 gig InfiniBand EDR requirements. And it can also be used, as Melissa mentioned, for the SFP Plus. It can be used for current 10 gig and 16 gig applications with substantial electrical margin. So some customers are designing in, especially our stack portfolio, but are designing in the surface mount connector for 10 and 14 gig applications. It is backwards compatible with current gen QSFP cables. So looking at the layout, and what we decided to do is to extend the footprint just a little bit. And the reason we did this, and I'll show you in the next couple slides, is to get improved electrical performance. So if you look at our Type A product, TE and Molex is EQSFP, Emichi and Amphenol have EQSFP. So EQSFP provides you the opportunity to design in the same footprint as the current gen QSFP connector. But if you look at the ZQSFP performance, you can see between 10 and 15 gigahertz, the performance is very good. So even for 10 gig applications, you'll have substantial electrical margin. So this is why we decided to go with the deeper footprint, although it's the same interface. So to go along with the surface mount connector, we have our single and ganged cages, and we're coming to market with everything right now. So between a 1x1 and a 1x6, we do have, and on the chart to the bottom right, you can see we have 3 different types of cages as well, but we have through bezel with gasket, through bezel with EMI springs, and then a behind bezel cage. And on any of these cages, one thing that we're trying to promote is that, you know, depending on your application, depending on your airflow and your thermal needs, we can do custom heat sinks, typically without NRE or any price changes. But with the transceiver MSA being at 4.5, the industry being around 3.5 right now in terms of performance, this is something that we really saw a need for. So if you need side-to-side heat sinks to accommodate for your airflow front to back, if you need a 17 millimeter height heat sink or a 2 millimeter height heat sink, we can do it for you. So here is where we are in terms of tooling. As I mentioned before, you know, we're trying to come to market straight from 1x1 to 1x6. We already have a lot of our behind bezel cages tooled, and the rest of our cages, so through bezel with gasket and EMI springs, will be tooled probably by the end of this calendar year. And one thing to mention here is that for each cage, if you're concerned about thermals, if you're concerned about EMI, the through bezel cages with the gasket and EMI springs have the same footprint as each other, so they're interchangeable solutions. It's the same distance on the PCB from the bezel, same bezel cutout, and we're actually performing EMI testing by the end of this month. So if this is something that you're interested in and you'd like to see, definitely let us know, and we can have a conversation with you on what configuration would be best for your system. So moving to our stack products, we see a lot of this market obviously being in the networking switch arena, where customers need very high density, either top rack switch or end of row. So we have 2x1 through 2x3 versions, both in EMI gasket and EMI springs with various light pipe configurations. And something different that we did here between Molex and us, we looked at the SFF specs, and we decided to go 2 different directions, or we're going the same direction, just 2 different options. You can either get each column of ports with 3 pins on the rear of each port, or 0. And this basically allows a customer the flexibility to use a different PCB. So if you're only looking at a lower cost PCB using surface routing only, the 0 pins per port will make it a lot easier for you. But if you're using vias and multi-layer routing, the 3 pins per port is a little bit better for thermal dissipation as well. And one thing that both TE and Molex are looking at is the integrated heatsink versions, which are in development. I'll show you a little bit of a concept that we've come up with recently. And we actually have prototypes and testing now. But this in stack solutions, especially anything greater than like a 2x2 with side-to-side airflow, will definitely need to consider some sort of thermal solution. So here's what we have tooled so far. So the top two rows, EMI gasket, EMI springs. But the one thing I want to mention too was the thermally enhanced footprint. So for this, really what this means is that the columns of ports are a little bit spread out. So instead of, in the picture on the bottom, each port is adjacent to each other, there's a couple millimeters in between each port to allow for additional airflow. Also, there's ventilation holes in between the upper and lower ports. And what we did was we put the light pipes on top of the cage, which are still able to fit in a 1U chassis. But we have this in 2x1 and 2x3 and a design for 2x2 in case you're interested. So I mentioned before, we're doing a lot of work on thermals, and this is just one idea that we've come up with that we're in prototype and testing right now. So passive cooling solutions, and the argument can be made for stacked connectors and for heat pipes, whether it's active or passive, but it uses no power, so we call it passive. So this is something where we've embedded heat pipes into a heat spreader in between the upper and lower ports, and we're bringing out the heat to the back of the cage or to the top of the cage where the airflow can cool, where there can be heat transfer to the air. So the chart on the bottom left-hand side, you can see there, we looked at two different scenarios, side-to-side airflow and back-to-front airflow. So what we did, we looked at worst-case solution. So we had 4.5 watt, fully populated, 2.5 meters per second airflow at 55 degrees C ambient. So you can see the significant temperature delta between the original design, which is just the bare cage with no heatsink or heat pipe, solution A, which is the heat sink on the back, and solution B, which is the heat sink on the back and the top. So, I mean, we're looking at a lot of other different options. If you'd like to engage with us and tell us what pain points that you're seeing, what solutions you're looking for, we can definitely, engage with you, and we can put our system architecture team and utilize our thermal expertise. We have a team of about 4 to 5 people just focused on thermal performance at this point. So we see it as a huge issue in the industry, and we're trying our best to solve it. But again, if you're interested in talking to us about the other solutions that we're doing, we'd be more than happy to accommodate. So I think I would be remiss if I did not put a plug in for our optics guys. So we have released last year at OFC, we released our CoolBit optical engines. And these engines will be found obviously in our midboard optics, in our CDFP transceivers, but also in our QSFP28 AOCs and transceivers. And the benefit of the CoolBit optical engines is that everything is vertically integrated. So we make the VCSELs, we make the drivers, everything. Which allows us to have proprietary technology and get down to power consumption of 1.5 watts per transceiver. The rest of the industry is about between 3 and 4, so this is significant power savings, not just dollar savings, but dollar savings in cooling your system as well. The applications and the standards that these support will be InfiniBand EDR and 100 gig SR4. We do have a full roadmap, so again, if you'd like to engage with us and see what we're developing and what our team is doing, they've done some amazing work, obviously for 1.5 watts, and we'd love to engage with you. Also, we are offering QSFP28 direct attach copper cable assemblies, and you know, we're vertically integrated with our Madison cable plant up in Massachusetts. And the one thing that I want to leave you with for QSFP28 for passives, right now we have compliant lengths up to 6 meters for 100 gig Ethernet and 4 meters for InfiniBand EDR. Last year at DesignCon, we were actually demoing a 7-meter 100 gig Ethernet passive copper cable assembly, which is, you know, very, very, very good performance. But if you'd like to engage with us again, this is another team in our group, so we can definitely have a different webinar, maybe for your team or for your development team. So moving on to a little bit higher density, I'm going to cover CDFP and CFP2 and 4, as these are more on the brink of coming to market. So CDFP, and I have one slide on this, just an overview. It's our solution, Molex and TE's current solution for 400 gigabits per second. So, you know, there's been talk about copper cable assemblies for short reach applications, and also optical solutions for up to 2 kilometers. And this solution right now is really the only concrete solution, I guess, that has been brought to market for 400 gig so far. It's 16 by 25. It's on a 0.75 millimeter pitch. Again, our optic solution includes our CoolBit optical engine, and this is 6 watts of power per end. So if you think about that, it's pretty much 4 QSFPs in a much higher density solution. But TE and Molex are providing identical connector solutions to the market. CFP2 and 4. So this is something that, you know, TE and some other players in the industry have toggled back and forth between wanting to support and not wanting to support. But, you know, the more we thought about it and the more we broke down the power consumption comparison and the benefits to you, our end customer, it really seemed like a good solution going forward. And, you know, current gen CFP is quite large. It's quite expensive, and it takes up a lot of faceplate real estate. So if you look on the bottom left-hand side, and this is a little comparison that we did internally for a 19-inch line card, assuming about 17 and a half inches of usable space. So current gen CFP, if you fit 4 CFP ports on a 19-inch line card, you could get 400 gigabits per second aggregate data rate through that line card, using about 128 watts of power. If you go to CFP2, you can double your data rate, and your power usage goes down to 96 watts. Fully populating with CFP4, you can look at 1.6 terabits per second, and your power usage only goes down to 48 watts. So obviously there's a significant density and cost advantage, total cost advantage, for going to CFP2 and CFP4. You know, there's still significant growth in CFP, and we see that market kind of moving towards 80 to 100 kilometer reaches. CFP4 more in the 20 to 40 kilometer reach, and CFP2 anything under 10 or anything under 20. Oh, sorry, other way around. CFP4 anything under 20. But also in the short term, we see CFP4 in the short reach market, but then really starting to compete with QSFP28 as the optics technology for mid or longer reach. QSFP28 becomes more advanced. So the proposals that we're bringing to the market, you know, for configurations, we're looking at the receptacle, the cages, the dust plugs, and heat sinks. This is something that our team, who sits, you know, 10 feet away from me, are working on right now. So we're working hard to get to 25 gig. We're looking at potentially using technology for 56 for next gen. But again, if you want to engage with us, please let us know. We're doing a lot of development work on these products right now. So just to close up a little bit, so some more information that we have. Obviously, we've done a lot of work in our catalog. So we still have a PDF paper catalog that's available for download online, or if you want a hard copy, we can send it if you're a little old-fashioned. Our landing page is te.com/product/pluggable.io, and we do have quick reference guides, that we can sit down and go over with you, which is pluggable.io solutions. We have ones for QSFP and ZQSFP. We also have a hard sample kit that we can send out to you, or in this picture on the right-hand side, you can see our high-speed I/O virtual sample kit, and this is a PDF, that you can scroll through and click on the link. It'll take you right to the part number page. You can order samples for any of our new products, and this is nice because we can update it, as we need to, and keep it out online. We do have, and one last plug for our marketing team, we do have a virtual tour on our data communications page. You can see here, if you go to industries and datacom, you can look at different applications and where our products are used. We also keep the latest news on 25 gig, on Whisper, on the new products that we have that are coming out. So here is the email addresses for Melissa and myself. We went through a lot in this presentation for ZSFP Plus and ZQ, which we see as some of the main drivers in our industry at this point. But we're doing a lot of development, as Melissa mentioned, on 0.6 millimeter pitch, on 56 gig I/O, and on other 25 gig solutions. So if you'd like to engage with us, let us know your pain points, and we've probably seen them before, and we can definitely help you with a solution to your needs. So with that, I think we're going to switch back over to Ashley for Q&A.
Yes, thank you. We're now going to open it up for questions. If you have a question, you can type it into the Q&A box. We did have a few that came in online, and so let me see here. The first question is, as the new high-speed I/O are backwards compatible, is there an expected end of life for the present 10 gig families?
Ashley, I can answer that question. So yes, absolutely there will be. Much like the transition that we've seen between our 1 gig product SFP and our 10 gig product SFP Plus, there will be a transition point. For SFP and SFP Plus, that transition point was this year. This year was the first time that we've seen 10 gig sales outdo those of the 1 gig sales. So that transition took about 5 years. Experts in the market are saying that the transition to 25 gig will actually be a lot faster than that. So from that standpoint, yes, there will be perhaps a decrease in our current 10 gig products. One of the other things to remember is that a lot of the sales that we've seen in 10 gig are in the data center and networking portions of the market. In wireless, there's still a growth potential there for 10 gig. Most wireless solutions are only going to about 4 gig right now. So while there will be some decrease, 10 gig will live on for what's expected to be 10 plus years.
All right, thank you, Melissa. The next question is, will TE offer heat sinks on the ZSFP Plus cages?
Ashley, I can answer that one as well, since it's my product. Yes, so the current released products do not offer heat sinks as of right now, but it is something that we are looking to add very shortly and should be a fairly simple addition to the products that we are releasing next month. Thanks for that question, by the way.
Our next question is, what is better in terms of EMI leakage, a cage with EMI springs or a cage with elastomeric gasket? Elastomeric, sorry.
Sure, so I can answer that one. So in terms of performance, they're actually about the same, but it really comes down to customer preference. So some customers will go with EMI gaskets because of less risk of tolerance stack up. But in terms of actual EMI leakage, EMI springs, EMI gasket versions, we've been looking at a bunch of different options. Seems that silver-plated copper performance doesn't really justify the cost difference between that and a nickel graphite gasket. So we're definitely looking at cost savings for the customer. The cost.
Actually, I don't know if you're getting a little delay from Lucas, but just to emphasize the choice between elastomeric is a customer choice. Can you just confirm that you're hearing me, or are there some technical issues, Ashley?
Melissa, I can hear you. Lucas, you were cutting in and out.
Yeah, so again, a customer choice, we have some data to kind of back up that the performance is really equal between the two if anyone's interested.
Okay. Thank you, Melissa. And our next question is, how much front panel capacity can be achieved with CDFP? Seems like the highest I/O density, right?
Lucas, do you want to try to take this one, and let's see if...
Yeah, I'm concerned about cutting out. So if we if we use about 15 ports, so 15 times 400 is about 6 terabits per second. That's off the top of my head what I think, but it might be a little bit less than that. But it definitely is the highest I/O density, absolutely. It's a very similar design to CXP, which is 12 by 10, but getting to 16 by 25 is huge for the market.
Okay, thank you. Are there any other questions? There's none typed in the box. So wait just a few more seconds and see if any pop in. Doesn't look like it. So that will conclude our Q&A. If you have additional questions, you can reach out to Melissa and Lucas, or you can leave them on the event page. The recorded version of the Hangout will be available online shortly. Thank you, everyone, for joining, and we hope to connect with you again soon.